All right. So do you want to start, Victoria, please? My name is, I want to introduce myself. So my name is Xavier Fresquet. I'm an engineer at Sorbonne University. I work in a team of musicologists and in AI center here in Paris. And I will be starting the presentation shared with my colleague Victoria, who's also here.
Yes, I'm Victoria Eyharabide. I'm an associate professor in computer science at Sorbonne University. I'm working on artificial intelligence applied to cultural heritage.
All right. Sorry. So the whole idea of this presentation is to show an experiment that we've been doing since a couple of months to try and detect automatically in IIIF images some illuminations in medieval manuscripts. And that's what we are going to present. And I'm going to give you some background on why we are doing this. So the idea is that we want to look at illumination. So we are not looking at the text, but we are looking at illustrations of various types of characters that are located on the pages and that have various sizes, various colors, various shapes, and various locations on the page as well. And because we are musicologists, what we focus on is what we call musical performance. Musical performance is of course related to music making and instrumental playing. So in the middle here, you have a picture of a woman playing a trumpet or a trump, or we can discuss that. But it can also be related to dancing, as you can see on the left, and it can also be related to singing. Here on the right, you have a group of singers singing in front of an open book with musical notation on it. And so that's the type of image we are looking at amongst other types of images that we are analyzing. Here we are focusing solely on musical performances in medieval manuscripts. So we are looking at images of musical performances that, of course, dates from different periods, and because they are from different periods, different locations, don't have the same shape, don't have the same colors, don't have the same styles, and that can be a difficulty when you want to automatically analyze these illustrations, and it can be a challenge, as we will be discussing a little later. What is important for us is to look at these instruments, for instance, to analyze specific elements. So for a harp, for instance, it can be the number of strings, it can be the presence or the absence of sound holes, it can be the presence or the absence of tuning key. It can be also the way an instrument is held. So to study the playing technique, to see that if there are some differences between the playing techniques, how a string is plucked, for instance, and if you use an instrument to pluck the string. And to be able to do so, we need many representations, and we need to be able to compare this representation. In that way, the fact that we have now IIIF as a tool is a great opportunity for us to find some new representations that we didn't have before. Of course, this work has a concrete goal. For instance, it can be to recreate some lost instruments, because medieval instruments are not often found in museums because they are too old, and we need historically informed iconography and musicology to be able to recreate, as close as we can, of course, these medieval instruments, to be able to recreate their sound and the way they were played and the performances were made. And of course, the work that we are doing it's really a small world. It's a team of musicologists working with a team of computer scientists to achieve this goal, and it resonates with some important works that have been done before, and with people that have been presenting in this conference. Actually, of course, we can think of the work of Dominique Stutzman with Orare, who was focusing on medieval manuscripts, not necessarily on the illuminations, but on the objects themselves. The work DH Segment, who also tried to analyze some images, as well as Doc Extractor in 2020. And as we will see in the rest of this presentation, the work done by the team around HBA, and we would like to thank also Jean-Philippe Moreau, who is part of the conference for this work, because for us it's been very, very helpful to try and develop this experiment and the technique that we will show you today. So HBA is really very, really an important work for us, truly. And I will leave the floor to my colleague Victoria.
So I will share.
Oh, yes, sorry.
The screen. Can you see my screen?
Yeah, perfect.
Okay, thank you. Well, let's start with an example. As Xavier mentioned before, our objective is to detect illumination in several IIIF page images using deep learning. In this image, we can see that for each illumination found in the page, the objective is to generate the IIIF URL only with the area containing the illumination. So this slide shows an overview of our proposal using the state-of-the-art YOLO, which is an algorithm for classification and object detection. We have three processes: training, search, and validation process. I will explain this process in detail. As Xavier mentioned, we use HBA corpus for training, but these images are not annotated with bounding boxes around illumination. So for each page, we randomly generate 10,000 rectangles and label those rectangles with their pixel-based annotation. After preprocessing, we train and validate YOLO with this subset of HBA images. So the HBA data sets came from Gallica. It contains real scan ground truth images from 11 historical books. They are green scale and color images, and the annotations include 6 classes, graphics, and different type of text, such as normal, capitalized, handwritten, italics, and footnotes. So what we did with this data set is first regroup all the different texts in a single category. So we obtain only 3 classes: graphics, text, and the regs, which is the background. Okay. Then we eliminate the images that do not contain graphics, that were damaged or with scanning defects. And as a result, we obtain 366 pixel annotated images using these 3 classes. Then, in order to train YOLO, for each page in a document, we generate bounding boxes from different sizes and annotated each rectangle according to the ground truth images. The new data set is split into training and testing subsets. So as a result, the prepared HBA dataset contains near 100,000 bounding boxes annotation with this distribution. Okay? As you can see, the annotation distribution is strongly balanced and accurate for training. The second step of our proposal is the search process. During this step, we start by analyzing each manuscript manifest to extract all the pages, all the images of the pages. After evaluating each page in the train model, we merge all the bounding boxes obtained to discover the illumination. According to the IIIF specification, as you know, a manifest has one or more sequences, and a sequence must have at least one canvas, and so on. So based in this well-organized specification, we read the JSON manifest to extract all the pages. We use the smallest and fastest base model of YOLO, which is version number 5. Okay? So after describe our parameters and modify the YOLO configuration, we make inference in the test images, and we obtain the result like this one, in which we have a graphics part, text, and the rest, which is the background on the margin. As you can see in this example, there are several and strong overlap between the rectangles that we detected by YOLO. So we developed an algorithm for combining all those bounding boxes into bigger ones that encompass areas of interest. Finally, according to the IIIF specification, when you request an image, should follow this syntax. And we are interested in the region parameter, okay? The region parameter generally has a full value as default, but we are going to replace this value with the coordinate given by our algorithms. The final step is the validation process. We ask a group of medievalists to create a ground truth dataset of IIIF images to test our proposal. But as manual annotation are really expensive in time and in knowledge, they annotate only one manuscript for each library in order to obtain a total of 1,300 annotated images. The experts selected 4 manuscripts. Although this dataset applies only to a limited number of documents, as the selected manuscripts came from different libraries, the idea was to demonstrate that our system could be applied to different collections. So the documents are now in the IIIF library in France, the University of Basel in Swiss, the Cambridge University in United Kingdom, and Princeton University in the United States. The first manuscripts is here we have an example. It's a document mainly containing a book of the Apocalypse published in the 9th century and is probably of Spanish origin. This document contains 40 paintings. The second one, here is an example. The second manuscript is a zoological work written in Greek by Aristotle. The decoration of the initial are rich in metaphor. Okay? And even this document contains 316 pages. Only 19 pages are illuminated. The third document is a gospel book with rectangular headpieces with vegetative ornaments. And the last one is the Bible probably produced in England. So to evaluate the performance of our proposal, we present this confusion matrix in which we compute precision, recall, and F measure. We also show the true positive, the true negative, false positive, and false negative values. For example, the manuscript in the IIIF library has 40 illuminated pages, and our system found 37 pages, which is quite good. But if you see this column, there are several false positive examples. This means that our system found graphics that are not real illumination. This is due to the characteristics of the test images that contain degradation properties and scanning error. Let's see some examples. Here there is a degraded page, a side book, and also sorry, a page with a ruler or a color palette. So our system considers, for example, the color palette as a graphics and return the detected areas as an illumination. Here we present more examples with cover pages and also some diagrams without colors in the middle, and also here some small decoration. The dimension of the objects to detect can be very small compared to the whole page. So downsizing the images could lead to complete erasing some of the objects, making them impossible to retrieve. Well, in conclusion, we obtain good results, but we should notice that the data set that we use for training is really small. It contains only 360 images. A larger annotated dataset should be necessary to improve the performance of our model. To finish, we present some true positive examples. For example, from this page, we obtain 4 illuminated regions with their corresponding IIIF URL. To summarize, we train YOLO version 5 on IHBA dataset to detect illumination in IIIF medieval manuscript using deep learning techniques. Our approach has positive results, but it's an exploratory work that needs to be improved. We propose several future research perspectives. First, to test our model on a much larger data set. Second, to build a virtual library of illumination through several collections or libraries. And finally, build a new data set of IIIF images dedicated to music, dance, musical performances, and sound. Thank you for your attention. Please do not hesitate to contact us if you have any questions or comments.
Thank you very much.
So it looks like we have one question in the chat, and it's, have you looked at RetinaNet for your data set?
At RetinaNet?
Yeah, RetinaNet.
Yeah, not for this experiment. No, we used with YOLO in this experiment just to take a look and to see how precise it could be using transfer learning.
So we have about 1 minute left. So we probably have time for one other question if anyone has another to ask.
I have a follow-on question to that for the RetinaNet. Actually more of a comment. The RetinaNet or some of the newer architectures separate object detection from object classification. And this seems like it would be a very good thing for your guys, is so that even though when you do pick the particular image, you can classify that into musical versus non-musical.
The problem is that generally the music instruments are so small according to the whole image that it's difficult to classify the whole page as containing music or not.
But I
right,
think,
just the image.
Yeah. But I think it could be a good option also. I mean, we should.
Yes, we can try.
Yeah, we could definitely try it. We are new this domain. And we've been working together for a long time, gathering and analyzing medieval musical performances on different objects, not only on the illuminations, but also on sculptures and different types of medieval objects. And most of them not available in IIIF because it's been done for quite a long time. And the rise of IIIF is really an amazing opportunity to develop and test all of these techniques, and the object detection and classifications models and tools are also improving very, very quickly. And so there are lots of opportunities, and I think, yes, RetinaNet is one of them, and there might be others as well. And that's what's quite exciting about this, this type of work.
Wonderful. Thank you both so much for a great presentation. We're at time, so I'm going to head over to the next session. Thanks all for attending. And again, we'll be sharing the recording of the session as well. And a reminder that you can always follow up with the speakers through Huba or via email. Yeah.
Thank you.
All right. Thanks
Thank
all.
you, Meg. Thank you
Have a
very
great
much
rest
for
of your
the
conference.
organization.
Thank you.
Bye.